And here we go. We're looking at now 1.2, arithmetic series. That's page 14 for yourself. We're sticking with arithmetic, so that means, hey, it's still got the same common difference stuff going on here. We're adding to the next term, but we're seeing a new word here, series. 1.1 talked about sequences, but now we're going to look at series and see how they're related, but slightly different. And I know one of my goals that I've told you is I want everybody to know, okay, why do you have to know this stuff? So this will be important to you later in life because there's going to be a test on it. Let's get started. So suppose this continues. What's the value going to be of the 8th term? So I do recommend, hey, try to pause this if you haven't gone through this yet. Try to do it yourself. Try to learn yourself first of all. So we're starting here, and then we've got a certain slope that's going to take us into the next ones. Now we don't put a line to join these because we've got an element of the natural numbers only. We discussed that in class there. But if the dots were to continue, then what would happen? Well, we're going up by 2. So our D is 2. So the last one here was 7, so it's going to be up from 2 from there. The next one, so that's going to give us 15. And then what's the expression for the nth term? In other words, what's the general term? The rule, the formula. So the way to go about that is start with your regular formula. So Tn equals T1 plus D times n minus 1. Fill in what we know. When we're looking for the general term or the nth term, we just leave the n as the n and the Tn as the Tn. So T1, hey, that's 1. Plus D, hey, we just said that that was 2. N minus 1. Let's distribute in and collect all of our like terms. So 1 plus 2n minus 2. Combine that, we get 2n minus 1. There's our general term formula. So now we quickly say, is 50 going to be one of the answers? Well, let's look at all of the values that we have to begin with. We've got we've got 1, 3, 5, 7. Ooh, those are all odd numbers. 50? It ain't going to be an odd number. Let's just prove it, though, algebraically. So if we say that, is 50 going to follow this rule of 2n minus 1? Well, add 1 over, gives us 51 equals 2n. Divide by 2. Well, n is going to be 25.5. Hey, n has to be a natural number. We can't have halfway through. Can't be the 25th and a half spot. So no, it's not. Really good thinking question here. You got 90 photos here. You want to put them in 5 rows. How many different arrangements can you make if the difference between the numbers of the photos in consecutive rows is constant? Meaning it's an arithmetic sequence. And again, I really encourage you to pause. Try this one yourself. Do the thinking yourself. Well, we've got 90 of them. There's 5 rows. That gives us 18 in each row if we just kept our difference to be 0. Hey, that's still technically an arithmetic sequence, even though it's not fancy or anything that we can really do with. But let's start there. We could put 18 in each row. So we would have 18, 18, 18, 18, and 18. Now, for all the other sequences, in order for it to work on both sides, if we're going to be adding in one direction, that means we're subtracting the same number in the other direction. So the middle row is always going to have to be 18 for this to work. From that point, now that you know that the middle term is always going to have to be 18, add and subtract numbers on either side so that you can get different arrangements and still add up to 90. So what if you go one less on each side? So then that would be 17, 16, and then 19, and 20. So really just move one from one row and put it in the other row. Or I could go down by 2. So I could have 18 here, and I could have, how about 20 and 22 there? Or, actually, let me put that on the other side there for you. I'll put 20 and 22 on this side, and then go down on the other side. So then we got 16 and 14. But you could go the other way. You could have less number at the top, more at the bottom, or you could have more at the top, less at the bottom. They're different. So I could have 20, 19, 18, 17, and 16, which is a different one. Or this one could have been flipped to be 22, 20, 18, 16, and 14. I'm going to let you continue on there and see all the different ones that you could have to bring it together. Let's look at what a series is. A series is the sum of the terms of a sequence. So if we take a sequence has all of those commas, and we have a related series. And a series has plus, or it could be minus, but we're adding the sum up of each term. Tn was used for the term, the value of the term that we were looking for. Sn is going to represent the sum of those terms. And then the nth term is the nth term, whether we're talking about the series or the sequence. They're still the same position of the term. So 5 is still the same first term in either the sequence or the series. All the difference is we put a plus sign in the middle. The first sum, T1. That's just add up the first term. It's 5. In order to find the second sum, we add T1 plus T2. 5 plus T8 gives us 13 for the sum of the first two. That pattern carries on. If sum of the first 3, sum of the first 4, we just add them up. Notice that 38 is really 24 plus the extra last term 4 of 14. Okay, first discussion question that we're going to start with in class is just think further. Why? Write something down. Be prepared to share. The deriving of the formula I'm going to actually go through with you guys in class so I can guide you through step by step how that works. But let's look at the formula that you've got here. Sn is equal to that. If we combine that with what we did in 1.1, we actually get a second formula as well. Both of these are on your formula sheet. Let's start using them. So a real nice formula-based question here. Determine the sum of the first 6 terms of this arithmetic series. They asked for a sum. That means we're going to use Sn. We've got 2 formulas to figure out which one do we want to use. So then let's look at what do each of these 2 need. This is the sum. This is your number of terms, your position. This is your n. When we're talking about the nth term, it's the number of terms. T1 is the first term. Tn is the last term. If we know those pieces of information, number of terms, first term and last term, we can use the first formula. Let's look at the second one. We need to know the number of terms. Same. We need to know the first term. But now, here's the difference. In the first formula, I needed to know Tn, the last term. In this one, I don't need to know that. I need to know the common difference. There's your distinguishing part. Do you know the last term or do you know the common difference? That's going to tell you which formula to use. So let's ask ourselves, what do we know here? Do I know what the last term is? Well, 1, 2, 3, 4, 5, 6. Yeah, I do, because this is the sixth term. That's the last term of what I'm asked to do. I do know Tn. Do I know the common difference? Yeah, I can figure it out. So I could use either or. Let's pick the one that's easier, the first one. Sn equals n T1 plus Tn over 2. Formula-based questions, always take it on the side and just write down all your variables and fill in what you know. So Sn, the sum, I'm looking for that. That means I got to know the other three. So n, number of terms, that's 6 of them. T1, hey, that's 25. And Tn, that's the last one I'm looking for, that's negative 30. And then now it's just straight plug it in. So n is 6, bracket, 25 plus a negative 30, bracket, divided by 2. And then we just work it through, and that gives us negative 15. So the sum of the first 6 is negative 15. All right, now they're going to trick it up a bit here. Arithmetic series, T1 is 3, D is negative 4. Find the sum of the first 25. That's what it's saying. They don't give us the last term. They do, however, give us the D. So let's start there. We know we're using the other formula, the one that has the D in it. N bracket 2 T1 plus D n minus 1 over 2. Formula-based question, again, take it on the side, fill in what you know. Sn, n, T1, D, and n. So D, I see that right there. That's negative 4. I'll fill that one in. T1, I see that. That's 3. Oh, I got 2 n's going on there. I don't need 2 of them. That's silliness. N. They didn't specifically say n. Oh, but wait. They did. Right here. Sn. So the n is the 25. Good. And let's fill it all in. Sum of the first 25 is 25 bracket 2 times 3 plus the D, negative 4, times n, 25 minus 1, all over 2. And working that through now. Now I know some of you will just punch that straight into your calculator as it is. Yeah, you can get to the answer. Some of you will go step by step. Fine, do that if you need to as well. Just get to the answer. So you got 25 times 6 plus 25 minus 1 is 24 times a negative 4. That's negative 96 over 2. 6 plus negative 9, so it's 25 times negative 90 over 2. And multiply that, we're going to get negative 1125 as our answer. All right, throw some decimals into the mix now. No big deal, we can do that. We need to find the sum of the first three, the first 3 terms of this series. We're given the sum. And we're also given, this is the key that you're always looking for, we're given the sum of the 15, and we're given the term 15. That means we know the last term, the Tn. So when we know the last term, we're going to use the formula Sn equals n bracket T1 plus Tn over 2. Formula based, hey, let's pull it on the side again. Sn n T1 Tn. All right, well, n. Hey, we know that we're talking about 15 of these things. Good. T1. No idea. Don't know it. Sn. Hey, I know that. S15. That's 93.75. Sum of the first 15. Tn. T15. 11.5. So even though it asks for the first three terms, I need to find term 1 first before I can find 2 and 3. Well, let's just plug her in and use our algebra. Solve. 93.75 equals 15 bracket T1 plus 11.5 over 2. Multiply the 2 up and over there, or divide 15 by 2. You could do either that. I'm going to multiply it up and over, so I got 187.5 equals 15 bracket T1 plus 11.5. You can either distribute it into 15 or divide it over. I'm going to distribute it into 15. I just find less mistakes get made at this point doing this. So 187.5 equals 15 T1 plus 172.5. Let's subtract that 172.5 over. And that gives us 15 times T1 equals 15. Divide by the 15. So then T1 is equal to 1. 1, 2, 3 terms. First one was 1. And then we're going to add the difference, which was 0.75 to it, giving us term 2, which is 1.75. And then again, add another 0.75 to it, that common difference, and you get 2.5. And there's your first 3 terms. All right, now the important part of the lessons are, let's actually apply this information. Let's do the problem solving. These are the most important ones. The bottom row of a trapezoid had 49 cans. Each consecutive row had 4 fewer cans than the previous row. There were 11 rows in the trapezoid. How many cans were in that trapezoid? Oh boy. Let's start trying to identify what each of these numbers are representing. The bottom row of a trapezoid had 49 cans. Just so you remember what a trapezoid looks like. It's like that shape. So at the bottom here, 49 cans. Oops. So this is really our bottom row. It's our starting point. We're going to make that our T1. Each row had 4 fewer cans. That means we're going to go down by 4 in every row. Hey, that sounds an awful lot like a D value, but going down by -4. And now this 11 rows. Hey, they're telling us how many rows, the number of rows. That's our n value. Well, we know a T1, we know an n, we know a D. Which formula lets us do that? The second one. All right, so we've got it written down, and now we just substitute. I've got my things written down there. I'm just going to fill them in. So I'm looking for the sum of the first 11. So that's 11 bracket 2 times 49 plus a -4 times 11 minus 1 over 2. Hey, I know a lot of you are going to say, hey, why don't we distribute that -4 in? Hey, why don't you go with 11 minus 1 first? Make it easier on yourself. Okay, so then we got 2 times 49 gives us 98 plus a -4 times 10 over 2. Hey, if you could go 11 divided by 2, I would suggest doing that now, but you can take it to a decimal if you want, say 5.5. I'm going to leave it as 11 there, divided by 2. And then go negative 4 times 10. I know that's negative 40. 98 minus 40 gives us 58 over 2. And then 58 divided by 2, that gives us 29 times 11. Hey, that's 319 of those cans. Boom, done. It's a written question. We should be given a written answer, so put it into a sentence form. There are 319 cans in this beautiful trapezoid. Yeehaw. All right, that brings us to the end of our series part. 2 questions that we can discuss. How are an arithmetic series and a sequence related? Connect those two. Suppose you know the first and the nth term. What other information do you need to determine the value of n? All right, see you in class.